Tab Talks presents How Much Do You Know About Our Solar System?
There are many amazing wonders on the earth and in the skies. Tonight, we're going to look at our universe in a way that many of us have not done before. To the novice who looks in the sky and wonders what's up there, well, after tonight, you'll learn there's quite a bit of mystery and fascination about our universe. This fascination can be depicted in some of the early movies by way of Hollywood. And of course, most times when we talk about space, the subject of aliens eventually comes up. Well, tonight we're going to skip the aliens and focus on the true science of our universe. Trust me, you won't be disappointed.
Nine, 8, 7, 6, 5, 4, 3, 2, 1.
Hi, this is Dr. Michelle, and I want to welcome you to another episode of Tab Talks, and I want to welcome our guest, Jasmine Khalil. Jasmine, welcome to Tab Talks.
Hello, how are you? Glad to be
I'm
here.
doing great. I'm looking at that great background. So everybody, if you can
Yes.
check that out, that's pretty cool. Okay. And it's just so appropriate for what we're going to be talking about today. How well
Yeah,
do
right?
we really know our solar system? Jasmine's going to kind of help us get a little educated on our solar system and just our universe in general, because we don't talk about that a lot. And let me give you some of Jasmine's background, because I think it is just like super fantastic. Jasmine is a research assistant in the Department of Space, Astronomy, and Meteorology in the University of Cairo, Egypt. She does research on binary central stars inside planetary nebulae. So she's going to tell us what that is. So if anybody's confused, trust me, she's going to let us know very soon what planetary nebulae is. And she wishes to carry on research on exoplanets in the future. She's also a freelance space and astro writer and speaker. And that's how I found Jasmine, because, you know, her credentials preclude her. So I'm really excited about her. Outside the realm of astronomy, she enjoys poetry and literature and urges us to check out the works of her favorite writer poet, which was Gibran Khalil Gibran. So everybody go out and find these writings because she highly recommends them. She can also be found on Twitter, and I'm going to put her handle on the screen so everybody can reach out to Jasmine if you'd like. And if you want to hire her or email her, she's an exceptional writer. And I don't know, this is the first time I've ever met like a real like astrophysicist and somebody who actually is going to know what they're talking about. So welcome to Tab Talks.
Welcome. Thank you so much. And thank you for the great introduction. Yeah, thank you so much for having me. I'm so excited.
Well, you know what? Jasmine was on top of it, everybody, because she's in Cairo. And, you know, when we set this up, we were having daylight savings time. And so
Yeah.
Jasmine is super on top of it, okay? Because we do have a 6-hour difference, I think.
Yes,
So thank
yes.
you, Jasmine.
It's okay.
Okay, I'm gonna pitch my first pitch to you here and see if we can just kind
I'm
of
ready
get this
for it.
plane out of the airport. Okay,
Okay, all
you're
right.
currently conducting research on binary stars. Can you explain to our audience first, what is a star in general?
Yes, sure. So, in the most basic sense, a star is a ball of gas, and the composition and types of these gases differ according to where the star is in its life. And I guess we will talk about star's life also. But generally, these gases are hydrogen and helium in the case of the most basic star, also in the case of our sun. But here comes a very interesting question. I mean, you would think what differentiates this ball of gas from any other cloud of gases out there in the universe? And to answer this, we have to examine the star closer. See, a star has two forces acting on it, an inward force of gravity and an outward force of pressure. And in a star, these two forces are in equilibrium for the majority of the star's life. And that's what we don't find in other cloud of gases out there in space. So these two forces action together give the star its shape and the status of the round ball of gas that we know a star to be. Yeah.
Wow. Okay, everybody. If you want to Google that, I know she's right. Okay, that is what a star is. So when we're looking up there, we see a star. There's a whole lot more going on than just the beautiful brilliance that we see.
Of course, yes, yes.
Jasmine, what would our audience find fascinating about stars? Because you've given us an excellent explanation of what they are, but what would they find fascinating about a star?
Stars, like any other thing in the universe, they have a life cycle, right?
Okay.
They have a birth, so to speak, and they have a very, very long, fantastic life, and eventually they die. Um, and when we say die in stars, what we really mean is that they turn into something else. They turn into another celestial body that is equally astonishing and beautiful. So that was the first thing. The second thing that fascinates me always is that, you know, when people always say that we're made of stardust and star stuff?
Yes.
Yeah, right. And so many people think that this is only in a poetic sense, but actually, it has a very scientific background. See, most of the elements, the chemical elements on Earth and inside our bodies, they first were created inside stars and out of the chemical reactions happening inside of a star, and later due to the explosions of star that we will also talk about. So I always find it fascinating that we actually have a direct and very true link to stars.
Stardust, because we depending on your background, some of us, if we know that we came from dust and we return to dust, you're suggesting that dust is stardust.
Oh my God, yeah, this, also an excellent take. Yes, right.
Wow. Okay. So what is the life of a star? We talk about they live, they die, but talk about what is a star's life?
Yeah, well, I always love this question because it takes us through a journey throughout the star's life, and we step at designated stops to see sort of like a screenshot of what the star looks like at these different stops. So we also have an image here to show showing the different evolutionary tracks of a star. And the stop that we want to make is at what is called a molecular cloud.
Okay.
So what is a molecular cloud? A molecular cloud is a cloud in space that is so full of gases. It has so much gas and so very dense, denser than most other clouds. And from this molecular cloud, a star is first born. So imagine you have a cloud in space full of gas, and that you have an external force, external high energy force coming into this cloud. Now, what happens is that because it's very, very dense, it starts to form clumps, little clumps inside cloud, and these clumps eventually turn into the core of the star. And there you have a star is born, actually, from this process. Yes, that's the first step.
So that's where that movie must have come from then. A
Yeah.
star it's actually born.
Yes, that movie, yeah, it most definitely had an astrophysicist trick. So after the birth of the star from this cloud, we then move into another phase. It's called the main sequence stage. And in the main sequence stage, the star is the most active in this stage. And actually, our sun is now in this main sequence stage. We find that most stars, some stars actually can go up to 100 billion years on the main sequence. Those are a lot of zeros, everybody. A billion is one followed by 9 zeros, and those are 100 of those.
Wow. Wow.
Yeah, long life of the stars. So yes, the main sequence is the longest stage of a star life. And after the main sequence, as we see in the image also illustrated, we have two different evolutionary tracks for
Okay.
stars. If a star is a medium type, it goes into one path. If the star is bigger, it goes into another path. For medium type stars, and by the way, our own sun is a medium type star. They
Okay.
go into another phase called the red giant. That is, the star becomes red and it expands in size to become a giant, right? And by the way, if you looked into the night sky, you can see that a red giant star is actually red, and you can observe it with the naked eye. That's very, very interesting. After the star of a medium size goes into a red giant, it then goes into the final resting place of the star, if you wish, called the white dwarf.
Okay, the white dwarf. Okay.
Yes, the white dwarf. And in the white dwarf stage, the star no longer burns any gases. It just stays in the calmness of space, enjoying the cold in space.
Wow.
And but the more interesting actually is the other evolutionary track of bigger stars. So bigger stars move into to become not red giant, mind you, but red supergiant, because they are much bigger.
Okay.
Yeah, and
I believe we're going to see a
af-
picture of that later. Yeah, you're going to show
yes,
us.
yes, of course, yes, we will. And after the red supergiant phase, now comes the exciting part, because after the star finishes the red supergiant, it is now so incredibly big that gravity actually pushes the star and it explodes in a very big and grand explosion called the supernova, and we will also talk about it in details later.
Wow.
The supernova is a very big explosion that would outshine the light of a whole galaxy as seen from Earth. It's incredible, and I will save the talk for it for the later questions.
Okay.
And after the supernova explosion, I see how fascinated you are and how in awe you are. I love this look. I love it. Look on your
Wow.
face,
I
right?
am. I really am.
Yeah. So
I
after
can see why you're
the very big,
fascinated. I can see why this is fascinating, because I mean, I didn't realize that, I mean, we look up and we appreciate the beauty of the skies. And it's so serene from where we are. You just have no idea that all these cosmic explosions and
are
growth and
happening,
life and death cycles are happening.
Exactly. I mean, and that's just stars. The universe is so much bigger, and it contains so many different types of other celestial bodies, all equally exciting and equally interesting. Yes.
Wow.
Um,
Okay, Jasmine, you got us. Okay. So we talk about that life cycle. Okay, you're working on a project now, and that's what I found so fascinating, involving planetary nebulae. Can you tell us what that is?
Yes. Okay. Well, I'm working on planetary nebulae, and first, let me clear off a misconception here, because planetary nebulae actually have nothing to do with planets themselves. Okay.
Okay.
They do not contain planets. They do not produce planets. They are not the remnants of planets. Nothing whatsoever to do with planets.
Okay.
Yeah, you will sometimes find astronomy confusing like that, but it's actually pretty simple underneath, as we will discuss. So,
Okay.
where where does the name come from if it has nothing to do with planets? Well, the first astronomer who observed planetary nebulae, William Herschel, he did so in the late the 1780s, a long time ago.
Okay.
And when he observed planetary nebulae, because of the morphology of the nebulae, they look round in the sky. He thought to himself, that must be where planets come from. But actually, he was wrong, as we later discovered. Uh, but the name
Wow.
stuck to, and we've just gotten used to the name, and now
It just stuck.
we didn't change it. So, to come to your main question, what is a planetary nebula? As we talked before, that stars have a phase in their life called red giant. After this red giant phase, and we also have an image for this.
Yes.
Yeah, the star starts to grow up in volume. Okay, it expands, and as it's expanding, it sheds out its outer layers. It sheds off its outer layers into space. So you could think of it as like it's changing skin, kind of.
It's changing
Yeah.
its skin.
Yeah, it's
Okay.
the outer layers of the gas are blasted out into space, so they form a cloud around the star. And actually, a nebula is Latin for cloud.
Okay.
So you get a central star in the middle, okay, and a bunch of gas around it. Does that make sense?
Yes. Okay.
Yeah, yeah. And from there you get a nebula that is a cloud around a star. That, and again, nothing to do with planets.
Nothing to do with planets.
Yes, it's very confusing, I understand. And actually, these planetary nebulae are important to us because it teaches us about what elements the center star sheds out and blasts out into space. So they're very important in astronomy. Yeah.
Okay. Now you've talked about these explosions, so I want to kind of backtrack on that again. Can
Yeah,
you
sure.
describe and share what that looks like and teach us? What does these explosions teach us?
Yes, so these explosions, and as we said, they're very, very great. They are grand in size. Thus the nova in the name. Uh, sorry, that's the supernova. Um, and actually, the last event of a supernova observed from Earth, it wasn't that long ago. It was back in the 70s, late 70s, when we last observed a supernova from Earth, and oh God, how I wished I had been there. This explosion, it was so big and bright, so much so that it outshone the whole full moon. I mean, it was brighter than the full moon,
Oh
and
my.
even observed in daytime. I mean, I would die to see an explosion in daytime. This is like top astronomy for me. uh, and so we also have an image of this explosion taken. Credit goes to the European Southern Observatory. Of course, explosion as seen from a professional telescope. This photo is not, of course, a naked eye photo.
Okay.
And yeah, these explosions, they teach us about the last moment before the star goes kaboom. It teaches us about this last moment. What elements are within the star? What elements does the star blast off into space? Um, what's the distribution of these elements and how far they go? Uh, so yeah, the astronomy community is so incredibly eager to witness another one of these supernova explosions from Earth. Yeah.
Oh, and you said that was in the 70s when that happened. I'm gonna
Yeah.
try to find that. Find that.
Okay.
Okay, so what's the current landscape of our solar system? We've talked about the planets and the stars and the atmosphere and the black hole. Can you just kind of give us a basic framework of our universe and our solar system so that people understand there are all these planetary bodies beyond stars? I think you touched on that.
Yes, sure. Yes. So the solar system landscape right now is obviously we have the sun. It's the only star in the solar system. We have our planets, the rocky planets, inward planets. We have the gaseous planets, the outer planets, and in between we also have between the orbits of Mars and Jupiter, we have a belt called the asteroid belt. And from the name, this belt hosts celestial bodies called asteroids, and they are basically just rocks, bodies of rock and dust that are believed to be the reason that brought water to planet Earth. Just a little fun fact there that when planet Earth was forming, it didn't have water on it initially. So water came from outside as a direct result from an impact on planet Earth. And so planetary scientists believe that these asteroids were the reason for water on Earth. Not only asteroids, also comets.
Okay.
It is believed that comets and asteroids are the reason for water on Earth. If we moved further out from the solar system to after the orbit of Neptune, we find another belt called the Kuiper belt. And I believe we have an image of the asteroid belt and another image for the Kuiper belt, yes?
Yes.
So the Kuiper belt hosts what's known as comets. And comets, as we said, in addition to them being the potential source for water on Earth, they are bodies of ice. So asteroids are bodies of rock between Mars and Jupiter. Comets are bodies of ice after the orbit of Neptune. Yes.
Wow, I don't think I'd ever heard that. Comets are bodies of ice after the orbit of Neptune.
Yes.
Okay.
And also not only in the Kuiper belt, in fact, if you went, well, not you, of course, if a spacecraft went out also after the Kuiper belt into the Oort cloud, what is known as the Oort cloud, OORT.
Okay.
The Oort cloud is a donut-shaped cloud that is after the Kuiper belt that also hosts comets and icy bodies. A lot of comets, a lot of icy bodies, and this incredible image we have here of the Kuiper belt and the Oort cloud demonstrates that. So that's our solar system in a nutshell. Fantastic.
You know what? I'm still trying to catch up with those extra planets they discovered, because I remember when I was in elementary school, we learned there were so many planets, and then they found more. How did they
found so many more. But yeah, I believe now the count goes to more than 4,000 confirmed discovered exoplanets outside our solar system, and this number is just fascinating to me. That we
4,000?
actually more, actually
More
even
than
more than
4,000.
4,000. Yeah, and those are just the confirmed ones. We still have so many more in the possible category, and so many more being even discovered with new spacecrafts and missions.
I found out that the brightest star in the sky at night is Sirius. And while the largest is UY Scuti, and I'm trying to get that name. Is it Scuddy, Scooty?
Scotty, yes.
Yeah, okay, UY Scuddy, and I'm trying to figure out why it's
you
named.
like to color your star, yeah.
Okay, what interesting facts can you tell me about these two stars? So we've got the brightest and we've got the largest. Let's start with the brightest.
Sirius is indeed the brightest star in the night sky. And a very interesting fact to know about Sirius is that, and get this, it's actually 2 stars, not 1. Yeah,
Wow.
in what we call a binary star system. And that's actually not uncommon among stars. So many stars walk around in a binary system, as in 2 stars around each other, or even a trinary system, or even a 4-star system or more. So that's not at all uncommon in astronomy. It has 1 star that is in the main sequence stage of its life. So it's a young star, so to speak. And that's called Series A. Of course, we have to give them letters to differentiate them. So the first one is Series A, and the second one, Series B, is a white dwarf star, which means that it's at the end of its life.
So are they in orbit together? Are they actually, they're connected somehow, or they're just so close together it looks like one body?
That's a very, very exciting question. Yeah. Well, they are not merged.
Okay.
They are, they orbit each other, like, because one star has a great gravitational influence. It captured the other star in its orbit, and now they're sort of like in a cosmic dance of stars. It's very, very beautiful and poetic, even.
Wow. Serious.
Yeah, serious. Yes, but we cannot actually distinguish this binarity by eye. You cannot see it with the naked eye, or even with amateur telescopes. You cannot distinguish that, of course, because they are so far away from us. But we shouldn't confuse that Sirius being the brightest star with it being 2 stars, because it doesn't work like that. That's actually not the reason. It might be confusing to think that, but that's not the reason. The reason it's the brightest star because the stars are intrinsically so bright and also relatively closer than other stars, so they appear brighter to us here on Earth.
But again, this is not from your at-home telescope. This is from a professional.
Exactly. Yes, actually, the Hubble Space Telescope. Yeah.
Okay.
Only with your naked eye, just a tiny dot in the sky.